Let's talk about chapters 5.1 and 5.2, solving linear inequalities. Linear inequalities in two variables can be written in the form of ax plus by less than c, where a, b, and c are real numbers. A and b, however, are not both zero. There are four different kinds of inequalities, not only strictly less than, but strictly greater than, less than, or equal to, and greater than or equal to. All ordered pairs form the solution to a linear inequality if it makes the inequality a true statement. Linear inequalities in two variables, written in the form of ax plus by less than or equal to z. Graphing a linear inequality. First, graph the linear inequality which forms a boundary line. So this is graphed just like graphing a linear equation. The less than or equal to and the greater than or equal to form either a solid or a dashed line. The dashed line, which forms the border region, is formed from a strictly less than or a strictly greater than inequality. Choose a point not on the boundary line and substitute that into the original inequality. If a true statement results from your substitution, then shade the half containing the test point. If a false statement results from the substitution, shade the other half of the plane that does not contain the point. Graph the related linear inequality Example 1. Graph 7x plus y strictly greater than negative 14. First, graph 7x plus y equals negative 14 as a dashed line. That is the border region. Your graphing techniques for graphing that border region should be similar to graphing linear equations. Choose a point not on the line. For instance, choose the point 0, 0 because it's convenient and easy to test. Testing that into the original inequality produces the statement of 0, strictly greater than negative 1. This is a true statement, so shade the side containing the point 0, 0. Look at the graph. See that the side containing the test point 0, 0 is shaded. Also note the dashed line forming the border region. Example 2. Graph 3x plus 5y is less than or equal to negative 2. First, graph 3x plus 5y equals negative 2 is a solid line. Because this is a less than or equal to statement, the border region forms a solid line. This is a graphic representation of the solution region. Pick a point again not on the graph. Again, convenient. Pick 0, 0. Test that into the original inequality and it produces the statement 0 less than or equal to negative 2. This is a false statement. So the other side or the other half of the line should be shaded. See the graph, the solid line, and the region that is shaded. Notes. Although all of our examples allow us to select 0, 0 as a test point, that will not always be true. So if you cannot choose 0, 0, then you must choose another convenient point on one side or the other of either the dashed border region or the solid border region. Solution of a system of linear inequalities. Graph each inequality in the system on the same set of axes. The solutions of the system are all the points to the graphs of the inequalities in the system. We are looking for common or overlapping regions here. Example 1. Graph the solution to the system y greater than x and 2x minus 4y greater than or equal to 6. First graph y greater than x, then graph 2x minus 4y greater than or equal to 6. Choose the common region between the two solutions. The solution of the system is the region in quadrant 3 that is shaded twice, both horizontally and vertically, including a portion of the line 2x minus 4y equals 6, which is a solid line. See the graph below. Okay, notice the overlapping regions, and notice that points that lie on the solid line in that solution region are also part of the solution. Note that you are not restricted in using this technique with only two inequalities. This technique can be used with 2, 3, or even more inequalities that form a system, following the same strategies and the same techniques.